I see we're going to start here. Double bond. There's a terminal methyl. Same situation again. You got the pick a methyl, any methyl you want. We'll number them backwards. It's like opposite the last one we did. So we got 8, 7, 6. Let's run these across. 5, 4. Now we're coming around the clubhouse turn here. I'm getting a little confused, so what do? I back up, I do the double bond here so it's easier to count across and find where I am. So look to this, double bond, there's 1, 2, 3 carbons. 1, 2, 3, there it goes. It's going to have a methyl up and a double bond. So there's your methyl, and here's your double bond. And this is a diene, so there are only 2 double bonds. So if I color that second one in, I know I'm home free, right? 4, 3, 2, 1. So we'll go 2, and then this diamond here is going to have the terminal alcohol. Just put the O, the red dot. See, that's all there is to it. Count across, there's straight 8 carbons in a row, 2 side groups, there's a total of 8, there's 9, 10. So again, when you see the C, it's 10. H's, O's, we can see there's 1 O already. So first thing we look for, the carbons that are totally accounted for. I see the number 4 carbon here, and I see the number 7. This is numbered correctly. You would start from the alcohol with the numbering. So color in carbon number 7. Color in carbon number 4. So you're going to find all these are 8 carbon longs, and you're going to see how having an OH or double bond somewhere makes it distinct. It'll have its own aroma to it. Go through, we'll put all our H's, we'll color them different from now on, but they all get red, let's say. So 2 methyls, there's 6 hydrogens right there. Here's another terminal methyl. These are all CH2s. Ah, and look, we got every kind of hybrid here. S, SP, SP2s, and SP3s. So there's a good one to stick with the color coding. What do we pick again? CH2s, I remember, are brown. Brown and orange. Got my new markers. So CH2s get orange hydrogens. CH2. CH2. So we'll color those brown, get them out of the way. And for you beginners, you don't have to do the color coding. This might be a little bit too complicated for some of you second graders, but definitely by the time you're in 4th grade, you should be able to do this. But if you want to color them all black or red like the suits and playing cards, color oxygen up there. Remember, go outside the line on the greens because these are real negative. Lots of electromagnetic negative South Pole kind of stuff going on. Okay, so these were the kind of wine-colored scarlet reds. SP3s are called. So there's a total of 10 carbons, 8 in the chain. That's how you name these. See, these have such common names from the old days when the name had something to do with where it came from. But technically, it's your longest chain, which is 8. So it's an octa. I see 2 double bonds. So octadiene 1-OL. It's a terminal, so you don't have to number it. But it's still a dimethyl, too. So technically, you would name it as a 4,3,4. You can't really call it, you wouldn't count that one, so you'd have to call it a 7,4-dimethyl. Then you got to name where the double bonds are, which are 3 and 6. Hey, you know what? Your omega fatty acids, they're all omega-3s. Look at the double bonds are right where the fats that are essential to your body are. All right, so we got the SPs, SP3s. We need SP2. What was the color we picked for SP2? It was kind of the purplish blue, right? So I love this because you can still see enough of the numbers through. They don't all have the numbers because of the black, but you're still able to count them and see where they are. Just the more you see these, the more you'll be able to memorize them. So GerANiol. It's from GerANiums. It's got that rosy smell to it because of the alcohol. Our next one we came across here is a octadienol also. But you know what it does? See, when there's double bonds, they're on one side. So this double bond here, instead of this going up, it's going to have to go down. So watch how that works. Everything else is going to be the same. So I'm going to look at the GerANiol and color all this the same. So I see a diamond to a methyl to a methyl to a double bond to number 6, straight over number 5, straight up to number 4, and that gets a methyl up there. And now what it's going to do is it's going to go to carbon number 3. Let's color that double bond in. This is called the stereochemistry again. When there's a double bond, it puts it flat because the bond goes up and down. So now this is going to go down, a carbon to an OH. To a carbon-carbon OH, actually. So go down, and then we'll run the terminal alcohol. So everything is still the same, except over here it took a cis direction on that double bond. Put your H's in. Methyls, get those out of the way. Those are easy now, right? They're on the end, nothing to it. CH3, 1, 2, 3. There's that 1, 1, 2, 1, 1, 2, 1, 2. So again, your C, H, and O going on. 6, 7, 8, 9, 10. There's still 10 carbons. There's 1 O, just like the geranium. We didn't count the H's on these. 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and that. So that makes it 18. Don't forget there's a proton inside that.